Good morning. 7.4 Dividing Properties of Exponents. Today we will be able to simplify monomials using the properties of exponents. So dividing monomials, monomials is 1. So any term that has one base. To divide powers with the same base, you need to subtract their exponents. Just like with multiplying, we are adding. Now we're dividing, we're going to be subtracting them. Okay, so a few different examples. The reason why is we can have x to the 5th, and we can write it out as x times x times x. And let me make this a little bigger. And then all over x to the 2nd. Well, if I have something on top and bottom that's the same, I'm going to be able to cancel them out. So this changes to x to the 3rd. Okay, same here, third, x to the 3rd to x to the 5th. Well, if I have 3 on top, and oh, sorry, it's an 8. 1, 2, 3, 4, 5, 6, 7, 8. These 3 will cancel out, and then I'll just have 1 left on top, 1 times 1, and then 1 over x to the 5th. So that this technically, we could do x, if I were to subtract them, 3 minus 8 would be a negative 5. And then I would want to put that under 1 so that it would be a positive exponent. Same thing as here. Okay? Just remember, multiplying powers with the same base, you're going to add the exponents. Power to a power, you're multiplying the exponents. Now we're adding in, we're going to be subtracting the exponents. So here we have 8 minus 2 becomes 6. This becomes, we have a negative exponent, so we're going to want to put it below. So this would be 1 over c to the 3rd. Come to this one, we have a lot of different ones. So 4 to the 11th cannot be simplified at all. I'm going to change this to 12. So here, well, and I guess the next one is kind of like that. So 4 to the 11th is going to stay. We have x to the 2nd, x to the 6th. So we are going to subtract those, and it would be a negative exponent, so it's going to stay in the bottom. So x to the 4th. And then y to the 7th, y to the 1st, so y to the 6th. Remember, this is a 1, and this stays on top because it would be a positive. Okay. Over here, we have a to the 3rd, a to the 2nd, so a to the 1st stays on top. Goodness. I have a 2 and a 4, so these can be reduced down to 1 over 2. So 1 over 2, and then b, remember this is a 1, so subtract them. I would want to probably get that out of there, so it would be a times b to the 4th all over 2, because this kind of looks funny, and I don't need that 1 there. Okay, my 4 is going to stay there, and then I have a to the 5th, a to the 2nd, so I'm going to subtract them. Comes a to the 3rd, and I actually get rid of my fraction. That's done. Okay, 3 and 5 can both be divided by 3. So if I wanted to break this down, let's do one problem like that. And then, well, it's going to be a lot of y's. 2, 3, 4, 5, 6, 7, 8. And then 15. I want to reduce that or simplify that down to 5 times 3, x, x, and y. Okay, so these x's would cancel out, these y would cancel out, these 3 would cancel out. So I have left an x squared on top. 2, 3, 4, 5, 6, 7, y to the 7th, and then my 5 is on the bottom. I don't expect you to do that every single time because you could just subtract them. This is just showing why we're doing it. Okay, 35 and 56. I believe 35 would be 7 times 5. 56 would be 7 times 8. Then we have, so the 7s are going to be factored out, so I have 5 and 8. So I'm going to erase that. Then x would be 3 minus 5 would be a negative 2, so I'm going to leave it on the bottom. I have a y on top and a y on bottom, so they both cancel out. And then a z to the 5th, because 6 minus 1. Alright, quick 5-minute lesson. We're going to move straight into 7.4 because this is all going to actually be on Monday. Alright, so to raise a quotient to a power, you need to raise both the numerator and the denominator to the power and simplify. A and B cannot equal 0. Okay, so if they do, this would be A to the n and B to the n. Okay, so like here, we have 3/5 to the power of 3. That means 3 to the power of 3 over 5 to the power of 3, which would equal 27 over 125, would be your answer. Okay, so simplifying, remember, recall your order of operations. You have to make sure this has to go into both of those. So here we have 2 to the 4th times r to the 4th all over 2 to the 3rd and r to the 9th. And then I can simplify this down. So 2 times 2 times 2 times 2. This equals 16. And then we have an 8, because 2 times 2 times 2. And then r to the 4th and r to the 9th becomes r to the 5th. And it has to go on the bottom because this would be a negative number. And then we have 16 and 8. So this can be divided out and equals 2. 16 divided by 8 is 2, and then over r to the 5th. Okay, order of operations, what do we do first? Well, the whole thing is being raised. So I have to do 3 to the 2nd. 5 times 2 would be 10th. Y to the 4th, 2 times 2. Then 5 to the 2nd. X to the 2nd, and y to the 8th. Then I can simplify. 3 times 3 is 9. 5 times 5 is 25. I'm going to subtract these, so it's a positive number, so we go on top. This would be a negative 4, so it's going to go on the bottom as 4. Double check that I can't simplify anything else out. This would be 3 times 3, and this would be 5 times 5. So a little more complex one. So we have 3. This whole thing is being raised to the power of 3. So we have x to the 15th, y to the negative 27th, z to the 9th, x to the 3rd, y to the negative 12th, z to the 9th. Okay, so I have a z to the 9th over z to the 9th. That's going to cancel out. I have x to the 15th minus, so 15 minus 3 would be x to the 12th. And here you have to look, negative 27 minus a negative 12. So this becomes a negative 15. So we're going to put it on the bottom as a positive. So y to the 15th. Okay, you can write an expression of the form a over b all to the negative n power by using the properties negative exponents. Okay, so if I have a negative exponent, this would go to the bottom and this would go to the top. So what I'm going to really do is just flip my fraction, but still that would get rid of my negative, but I still need to both of these are going to be raised to the n power. Okay, so here, first thing I'm going to do is I'm going to flip my fraction. So I have 5b over a all to the 2nd power. Then I'm going to distribute. So 5 to the 2nd, b to the 2nd, a to the 2nd. This is the only thing I can simplify down. So it would be 25 e to the second over 8 to the second. Oh. Okay. Again, here I'm going to flip it first. So y to the fourth. Oh, no. Or y to the fourth, yep. 2x to the sixth, all raised to the third power. So this equals, and now I have a power raised to a power, so y to the 12th, 2 to the third, x to the 18th. Again, this one is the only one that I can actually simplify down to 8. Okay, last one, maybe a little more complex one. Flip it, y to the fourth, 3x to the second, all raised to the fourth power. Okay, so we have 5 to the fourth, y to the 16th, 3 to the fourth, x to the 8th. Times 5 is 25, times 25, that's 625. 5 to the fourth is 625, y to the 16th, 3 to the fourth becomes 81, x to the 8th. That's your final answer. Okay. Assignment is 442, 953 odd, 71 through 77.